exponential functions. Exponential functions. We're going to talk about exponentials today, and we're going to talk about logarithmics on Thursday. They're inverses of each other, okay? Exponential functions, ladies and gentlemen, look like this. They look just like this. Do you see what is in the exponent? There is a variable. So in an exponential function, you're going to have a variable in the exponent, okay? Your a, your base, is always going to be greater than 1. So that's a good thing to remember. If you have 1 to the x power, it's a constant function. It just equals 1. That's what that says here. All right, looking at these functions, exponential functions, the big number is the base. So if I said to you, if I have 12 to the x power, what is the base? You guys tell me it's 12. All right, that's very important to understand. So your base is the big number, and then your exponent, your x, is going to be your variable. So you have basic questions like this that just says to evaluate. That just means plug in. So for like letter A, do this with me. My function is 3 to the x. They want me to evaluate where x is 5. So you're literally just going to say 3 to the 5th power. What that means is 3 times 3 times 3 times 3. In your calculators, all right, if you guys don't have a power button or don't know how to use it, there's something called a caret. It looks like the top of an arrow. That's what that means when you raise something. So if I did 3 to the 5th power, I get 243. If you don't know how to use your calculator, over the next couple days, we need to really figure out how to do that. Because if you don't have a calculator and you don't know how to use one, you will not do well on this assessment, okay? If I look at B, all right, B, I'm taking my function 3 to the x, and they want me to plug in negative 2/3. So I literally am going to say 3, hit my caret button, and then negative 2 over 3. Some of your calculators let you put in fractions. Some of you have to hit the divided by button. Another thing I want you to notice in your calculator, guys, that is a negative sign. It's not the minus sign. So if you did this in your calculator, you hit 3, hit the caret button, and I have negative 2 divided by 3. And I get 0.4807. You guys get the same thing? Anybody?
Yes.
Okay, thank you. Yes, question. All right, so the next one, guys, if I say C, 3 to the x power, they want me to plug in pi for x. So you would, in your calculator, you would hit 3, probably that caret button, and then put the pi symbol. So when I do that, I have 3 to the pi, which is, where's pi in my calculator? Oh, I found it. So 31.544. You guys with me? You agree? And then D, they're telling me to plug in square root of 2. So I would say 3, and then I'd raise it to the square root of 2 power. So in my calculator, I hit 3, that caret button, and then in the parenthesis, I hit second square root 2. Now, the reason that I'm doing all of this today is so Wednesday we can practice. You need to have a calculator that you're going to use on your test and quiz so you can practice. You cannot ask me the day of, be like, hey, did I do this right? Or can you help me? I can't. Then it's too late. So make sure you guys know how to use the calculator that you have, okay? Moving on to the next, guys, we're going to talk about graphs of exponentials. There's some things I want to talk to you about. And this goes for exponential functions, so write this down. For exponentials, we're going to talk about logarithmics later on in the week, but this is for exponentials. For every exponential graph you have, your domain is always negative infinity to positive infinity. Always. It's going to continue to get wider in both directions. Another thing I want you to write down and remember is that there's no vertical asymptote. Okay, the graph of an exponential can look a couple different ways. It can go like this, or it can go like this. It's going to get really, really, really close to a horizontal line, but not touch it. That's going to be our horizontal asymptote. But there will never be a vertical line that your function is going to get close to and not touch. So in exponentials, it's really, really important to remember that your domain is always negative infinity to positive infinity, and there's no vertical asymptote. All right, I want you to write down here that range, write this down because you're going to need this for your web assign. Range is based upon your horizontal asymptote. It's going to be a line that says y equals. Your range is either going to be from negative infinity to that or from that to infinity. Just two different options. But you're going to have to be able to tell the range, so that's important. Very similar to how we did with our parabolas. Everybody got that? Okay. All right, so if you notice, I have here, I'm going to say f of x equals 3 to the x. And then over here, g of x equals 1/3 to the x. What do you guys notice about these two? Anything? Do they look kind of similar?
Yeah.
A little bit.
They are.
They're reciprocals of each other. Notice this is a number greater than 1, and this is a number between 0 and 1. All right, this is going to be a growth. It's a whole number bigger than 1. This is going to be a decay. If you were going to plot points, because if you don't know what it looks like, you're going to plot points, x and y. All right, I always tell everybody to do -2, -1, 0, 1, and 2. I will tell you, if I'm going to have you graph, I'll tell you what I want you to plug in, so it's easier for me to check. But when I plug this in, when I say 3 to the -3 to the -2, when I do that in my calculator, I have 3 and I raise it to the -2 power, I get 0.111. Then when I say 3 to the -1 power, I get 0.333. What's 3 to the 0 power? 1. Good. Anything to 0 power is 1. What's 3 to the first power? 3. What's 3 to the second power? 9. So if I was going to graph this, and I'm just doing this quickly, guys. If this is 1 right here, my graph is going to, there's at -2, there's a point here, and then it's like here, then here, then here, then here. So it's going to get really close to y equals 0, but not touch it. Do you see, guys, we read graphs from left to right. Do you see why this is a growth? What's it doing from the left-hand side to the right-hand side? It's going where? It's going up. So on the opposite end over here, I'm going to do -2 to +2. And when I plug this in, when I say 1/3, so I'm going to say 1 divided by 3, I'm going to raise that to the -2 power, I get 9. So then when I plug in 1/3 to the -1, I get 3. 1/3 to the 0 power is 1. 1/3 to the first power is our 0.333. And 1/3 to the second power is that 0.111. So when I plot my points, I'm at -2, 9 up here, then at -1, 3, then at 0, 1, and then here. So when I read from left to right, what is my graph doing there? It's going which way? From left to right, what's that purple graph doing? It's going down. This is a decay. So do you see the difference between the way this looks? If I asked you, what's the horizontal asymptote? What is this line that this is getting really, really, really close to but not touching? Y equals what? Y equals 0. This horizontal asymptote would be at y equals 0. If I said to you guys, okay, you guys can tell me the range. All right, think about our parabolas. Range is from bottom to top. So down here is -infinity. Up here is +infinity. And here's my dividing line at y equals 0. So where does my function exist? Is it from -infinity to y equals 0? Or is it from y equals 0 to +infinity? Y equals 0 to +infinity. And I'm going to use parentheses. Why am I using parentheses? Does it include 0? Does it touch 0? No. So your asymptote, write this down. Your horizontal asymptote depends upon what is added or subtracted to the function. So on WebAssign tonight, they're going to say, well, what's the asymptote? And then tell me the range. They might give you a picture, they may not. But if I give you a function that says f of x equals 2x minus 7, and then I say to you f of x equals 1/2 x plus 3, g of x equals negative 5x minus 1. Okay, let's talk about this for a second. I want you guys to tell me for all three of these examples, and we're going to do this together, I want you to tell me if it's a growth or a decay, and I want you to tell me what the horizontal asymptote is. So the horizontal asymptote at this function, I told you it is based upon what's being added or subtracted. Remember, what does that mean if you minus something from the end? What does it do to the function? It moves it which way? Up and down? So my horizontal asymptote is not at 0 anymore here. Where is it at? Y equals what? Y equals what? Negative 7. Is this a growth or a decay? Is that bigger than 1 or smaller than 1? Bigger than 1, so it's a growth. Is there a negative in front of it that's going to say that it flipped over? No, so you know it's going to go something like this. It's going to go upwards. So when you have to tell me the range, is it from negative infinity to negative 7, or is it from negative 7 to positive infinity? Where's my range? Negative 7 to infinity. Good. So I look at this next one. Is this a growth or a decay? Is that number bigger or smaller than 1? Smaller. Okay, so it's a decay. It's going downwards. Is there a negative in front of it that flipped it over? No. Okay, so where is my horizontal asymptote? My horizontal asymptote exists at? Perfect. Y equals 3. So think about this. This line right here is y equals 3. So is my range from negative infinity to 3 or from 3 to infinity? Where does my function exist? Right here, right? So your range would be from 3 to infinity. So now, same thing here, same concept. Where is my horizontal asymptote? At y equals negative 1, right? Now this is a growth because it's bigger than 1. But what does this tell me about my function? It flips it, right? This is a normal growth that we're talking about. But since there's a negative in front, that means it's really flipped downwards. So what does that affect? That affects my range. If this is negative 1 right here, what is my range? Is it negative infinity to negative 1? Or is it negative 1 to positive infinity? Where does it exist? Good. Negative infinity to negative 1. Good. So you guys need to be able to visualize those things. I know that this is the first time you're seeing that with exponentials, but you have not, this is not new. The vertical shifts up and down and your reflections, that's not new. So we need to make sure it's the same concept, guys, if you had parabolas. Remember, if we have a positive parabola, it's going upwards. If you have a negative parabola, which way is it going? Down. Same thing with the reflections. Good. All right, here's just some pictures of growth and decays so you guys can visualize what it looks like, that sort of a thing. This is exactly what I just talked about, how it increases rapidly and that sort of thing. Growth and decay. This is a growth on this side because from left to right, it's going up. This is a decay because from left to right, it's going down. The way that that happens is if your base is bigger than 1, a whole number, it's going to be a growth. If it's a fraction in between 0 and 1, it's going to be a decay. All right, same thing, just look at at this. All right, if I was going to compare the rates of growth, guys, this is just like finding slope, right? If I wanted to compare the range of, or the growth, this is an exponential function. And this is a quadratic. How did I know the one on the right was a quadratic? How did I know the one on the right was a quadratic? Guys, how do you know the one on the right's a quadratic? How do you know this is a quadratic? Because it's x squared. How do you know this is an exponential function? Where is the exponent? I mean, where is the variable? In the exponent. If you guys were trying to compare, I'm not going to go through this whole example because this is very self-explanatory, but if I was trying to compare over the intervals of 0 to 3 and 0 to 8, they're telling me what to plug in. 0, 3 and 0, 8. They want to see how this one changes and how this one changes. So all you're doing is just plugging in. For your x value, they're telling you to plug in for y value. They want to know what the rate of change is. And you'll see, we don't have to talk about it. It just talks about how exponentials grow very rapidly. Unfortunately, coronavirus is a really good explanation or example of an exponential function. One person gets it, then 3 people get it, and then so quickly as we reach out and see different people, more and more and more people, it grows exponentially. I'm sure you guys have heard that. All right, last thing I want to talk about, and this is real world applicable. I'm going to go through this with you right now so we can do this on our calculator, but we're talking about compound interest, right? This is the formula for compound interest. I'm not sure if we're going to give it to you or if you guys are going to be expected to memorize it. So let's pretend that we're going to memorize it. But here is our formula for compound interest, all right? Bunch of letters and stuff like that. Right here below tells us what those letters mean. Principal is the amount, write this down, that you start with, all right? Your principal amount is what you start off with. They give you $15,000 to invest. If you have $2,500 from your job, whatever, it's the amount that you start with. Your interest rate is going to be R. You guys have seen that a million times. There's an interest rate of 3.6% or something like that. But the thing that you have to remember with your interest rate, it has to be in decimal form. And the reason this is really important, guys, if I tell you that an interest rate is 2.3%, is that in decimal form right now? Yes or no? Is there a decimal in this? Yes. But is this in decimal form? No, it's in percentage form. How do you change from a percent to a decimal? You go over 2 places. So 2.3% as a decimal is actually 0.023. Makes a huge difference when you plug it into a formula. So make sure you guys pay attention to that. Time is, T is just the number of years. So, I mean, that's very self-explanatory. But the number of times that the interest is compounded is going to be given to you in word form. The next slide shows you that. You need to be familiar with what these words mean. If someone says to you that something is compounded annually, in that formula that we just had, you would use N equals 1. If something is semi-annually means twice a year. So you would use 2. If they said something is compounded quarterly, well, quarterly, guys, how many quarters are in $1? How many quarters are in a football game? How many quarters are in an hour? It's 4. If something's compounded monthly, you would use 12 because there's 12 months in a year. And if something was compounded daily, it's 365. So this chart right here is super, super, super important because I'm going to give you guys word problems. And I'm going to tell you the same information here. This amount, your principal is 1,000 that you invested at a rate of 12%. Find how much is in there after 3 years. Okay, that's all principal, rate, time. But then if I say it's compounded semi-annually, you have to know, oh, the N variable is 2. So let's go through this. I'm going to do all of these together with you. We're going to practice in our calculator. We're going to do annually. I spelled annually wrong. We're going to do semi-annually. Spelled that one wrong. We're going to do quarterly, monthly, and daily. And I want to talk to you guys about putting this in your calculator, what the amounts look like, that sort of thing. But the principal that they told me that we're starting off with in this account is $1,000. The interest rate is 12%. So as a decimal, that's going to be 0.12 in our formula. And the time is after 3 years. So you're going to take that big formula that we had, A equals principal times 1 plus, what was it again? What over what? R over N raised to the NT power. So when we do annually, annual is when N equals 1. So I'm going to say 1,000 times 1 plus, and I have 0.12 over 1, raised to the N times T, so that's going to be 1 times 3 power. In your calculator, guys, I would, whatever this is, I would simplify it before you put in the calculator. So I would go like this. 1 plus 0.12, 1 times 3 is 3. Now, when you do this part, you need an extra set of parentheses. You don't really need it for when it's divided by 1, but for all other times you're going to want that. So let's practice. If you have a calculator, let's do this. We need to practice. It's 1,000 times 1 plus, and I have 0.12, and we raise that to the third power. And I got $1,404.93. You shouldn't have 20 million decimal places after it. We're talking about money, so it should end pretty finitely. So now if I'm going to do semi-annually, how does this change? And again, you guys may not have a calculator or anything like that, so you can follow along with this later. But how does semi-annually change from what we just did with annual? What changes in my formula? Guys, what changes in my formula? I still have my principal as 1,000. I still have the same interest rate, but instead of N being 1, now N is what? 2. So in my formula, I have a 2 here, and then when I say N times T, it's N, which is 2, times 3 years. So before I put this in my calculator, I would simplify and say 1 plus 0.12 over, 2, and that's raised to the 6th power. Do you guys notice, look, this is important to put a double parenthesis there. If you don't, your calculator won't do it right. And you'll tell me, my calculator says this. Your calculator is only as smart as the user, guys. You got to tell it what to do. So I have 0.12 divided by 2, and that's raised to the 6th power. So I have $1,418.52. All right, so now I'm going to work it out again. We did semi-annually, we did annually, so now we're going to do quarterly. So the only thing that changes here is N equals 4 in this case. So I have 1,000 times 1 plus. I have my 0.12 over, instead of 1 or 2, it's over 4 this time. And then I raise that to the 4 times 3 power. So I have 1,000, 1 plus 0.12 over 4. 4 times 3 is raise that to the 12th power. So in our calculators, 1,000, 1 plus 0.12 divided by 4, raised to the 12th power, and I get $1,425.76. Okay, 2 more, and then I'm going to compare these answers. Now I'm going to talk about monthly. Well, now monthly, guys. What does monthly mean when I talk about N, my compounding? Monthly is what? How many months are in a year? 12. So again, we have 1,000, 1 plus. I still have my 0.12, but now it's going to be over 12, and I raise that to the 12 times 3 power. So 1,000, 1 plus 0.12 over 12, raised to the 36. So 1,000, 1 plus 0.12 divided by 12, raised to 36. $1,430.77. And now I'm going to compound daily. How many days are in a year? 365. So I have 1,000 times 1 plus 0.12 over 365. And I'm going to raise that to the 365 times 3. This is why I think you should most definitely simplify your exponent before you put it in your calculator. So 365 times 3 is 1095. 1,000 times 1 plus 0.12 divided by 365. Raise that to the 1,950, and I get $1,433.24. What do you guys notice about all of these amounts of money, all 5 of these amounts? Are they all really, really, really far apart? Or are they all relatively close to each other? They're relatively close, okay? That's something that you guys need to be aware of, because what's going to happen, as soon as you guys get an actual calculator in your hand, you start plugging this in, you're going to get ginormous numbers. Like you're going to get $1,404 for annually. And then when you do quarterly, you're going to get, I got 17 million. When that happens, you should say, wait a second, I must have put something in my calculator wrong. I must have not put a parenthesis or something like that. Because no matter how you compound the interest, if you're using the same amount to begin with, the principal, you're using the same interest rate and the same time, amount of years, how you compound the interest does not change the value that much. If you notice, the difference is like $30. So be aware of that, guys, because some of you you're gonna get some ridiculous e to the 12th power or something like that, and you're gonna put that on a quiz and be like, how did I get that wrong? Because you're not paying attention. We're gonna practice this a whole bunch. Oh, my nose is so in my hair. We're gonna practice this a whole bunch on Wednesday, okay?